Welcome back, students. Now, the next topic is transitive relation. A relation R is said to be transitive if AB belongs to R. That means A and B are related, B and C are related. That will imply that AC is related. Or equivalently, you can write in this way: A is related to B is related to C, that implies A is related to C. To understand this concept, we are taking one example. Two divides 4. 2 divides 4. 4 divides 12. It implies 2 divides 12. Now, this is a very fundamental fact we know from our previous knowledge. Let us convert it into this new frame. Let us define one relation in the set of natural that divides. We are taking A is related to B. That means, are you getting my point? AB belongs to the set of Z. Now 2 is related to 4. 4 is related to 12, implies 2 is related to 12. That is the transitivity. So divides is a transitive relation. Let us take one more example. Example 2. Less than equal. A is related to B implies A is less than equal B. Now, what do you think? Is this a transitive relation? Is this a transitive relation? Yeah. If you think this is a transitive relation, then you will send the answer in the WhatsApp group. This is for you. This is for you. Homework. I am giving one more example. This is also for your homework. A is related to B. That implies and implied by A is friend of B. Friend of B. What do you think? This is a transitive relation? Yes or no? This is also your homework. You should write in the WhatsApp group. Yes or no? Obviously, you will give your names with the WhatsApp message, and I will do one more for you. example 4, because these relations are very important, so you should be very careful about them. Let L is the set of all lines in a plane. We are defining a relation R. L1 L2 belongs to R by this relation. L1 is parallel to L2. This is a transitive relation. Sorry. L1 is parallel to L2. Now take another. L2, L3 belongs to R. So L1 is parallel to L2, L2 is parallel to L3. This implies L1 is parallel to L3 and show L1 and L3 are related to one another. Are you getting my point? Okay. Now there are some problems so that the relation R on this set. Okay, now let us take its solution. R equal, this is problem number 1. It is given now 1 1 belongs to R, 2 2 belongs to R, 3 3 belongs to R. So this relation is reflexive as 1 1 isn't it? What about the symmetricity? Note 1 2 belongs to R, but 2 1 doesn't belongs to R. So whether this relation is symmetric or not? Yes, R is not symmetric. Yes, you are correct. Not symmetric. Now 1 2 belongs to R, 2 3 belongs to R, both 1 2 2 3, but 1 3 doesn't belongs to R. So it is not transitive. Actually, this is a problem from your textbook. What actually for transitivity, this is a word of caution. For transitivity, you have to find the pair in which the common element should be in the second place and first place of two elements. Am I clear? Two This 1 is related to 2, 2 is the second element, and 2 is related to 3. In this element, 2 is the first element. So 1 2 and 2 3, 2 and 2 will be cancelled out. Uh, that is not actually cancelled out. We understand in this way. So 1 and 3 will be related. Are you getting my point? Now the problem number 2. The problem number 2. Here it is. A relation S on the set of real numbers be defined uh, as AB belongs to S if and only if A plus B is greater than 0. Let us first check whether it is reflexive or not. Let us write the solution. Let us write the solution. Okay. What is A? A and B both are real numbers. Now A into A, that is A square. A square is always non-negative. So 1 plus A square will be always positive. So A belongs to the set S for every A belonging to R. So this relation is reflection. Second, for symmetricity, this is for reflexivity. Let us write it. Okay, this is reflexivity. Now for symmetricity, AB belongs to R. This means they are real number. Now let AB belongs to S. A and B are related. What does it mean? 1 plus 1 plus AB greater than 0. Now can I write this? Why? Why? Because AB equal BA, commutativity of multiplication in real numbers. Can I write BA belongs to R? Sorry, not R. Very sorry. S. So this relation is symmetric as well. Symmetric. S is symmetric. Now for transitivity. What do you think? Is it transitive? No. And this is a special type when the relation is not transitive, or not any relation. You have to find one counter example. What is counter example? Counter example is an example which does not satisfy the given definition. Okay, let me take one example, one counter example. Uh, okay, take 1 and 1 by 3. 1 and 1 by 3. This is A, this is B. 1 plus 1 into 1 by 3, that is 4 by 3. Obviously it is greater than 0. It implies 1 1 by 3 belongs to the set S. 1 by 3 minus 2. 1 minus 2 by 3. This is A, this is B. Here the relation ends with 3. Here the relation begins with 1 by 3. And this is 1 by 3, which is again greater than 0. So 1 by 3 minus 2 belongs to S. 1 and 1 by 3 are related. 1 by 3 and minus 2 are related. Now, if the relation S is transitive, then 1 and minus 2 should be related, otherwise not. Now, let us 1 by 3, 1 is related to 1 by 3, 1 by 3 is related to minus 2. 1 minus 2 are related or not. Let us check. 1 minus 1 into 2, that is minus 1, greater than 0. Is it true? No. So 1 and minus 2 are not related. 1 and minus 2 are not related. Now what are the result? 1 is related to 1 by 3, 1 by 3 is related to minus 2, and 1 is not related to minus 2. So the relation is not transitive. Good. This is another problem, and we have to show this relation is neither reflexive nor symmetric and nor transitive. In this type of problem, always we should have counter example, as I have told you earlier. Now for reflexivity we have to find one counter example. What is meant by reflexivity? For reflexivity, A belongs to R for every A belonging to the set of real number. This is the requirement of reflexivity. Now take A equal half. Half is less than half square. Is it true? No. So half are not related. In fact, every real number between minus 1 to 1, this relation doesn't hold. we can write this like A doesn't belongs to R for A belongs to -1 to +1 -0. Okay, so this shows the relation is not reflexive. Take 1 3. 1 3 belongs to the set R. 1 is less than equal 3 square. Yes, it is true. So 1 3 belongs to R. Now 3 1. 3 is less than equal 1 square by the requirement of the definition of R. Is it true? No. So 3 1 doesn't belongs to R. 1 3 belongs to R, but 3 1 doesn't belongs to R. So this is not symmetric. For transitivity, let us take 2 minus 3. Are they related? Let us check. 2 is less than equal minus 3 square. Correct? Yes. So 2 minus 3 related. Minus 3 1. For transitivity, where you end this, you have to begin from that element. Minus 3 1. Are they related? Let us check. Minus 3 is less than equal 1 square. Yes, that is true. So they are also related. Now we have to check whether 2 1 are related or not. What do you think? 2 is less than equal 1 square. Is it true? No. That means let us write 2 less than equal 1 square. Is it true? No. What does it imply? 2 1 doesn't belongs to R. So 2 minus 3 belongs to R, minus 3 1 belongs to R, but 2 1 doesn't belongs to R. So this relation is not transitive as well. This shows not transitive. Next question. This relation is, we have to check whether this relation is reflexive, symmetric and transitive. Now what is the relation? R, x is related to y if x is wife of y. No human being can be wife of himself or herself. So XX, because that is our societal norms, doesn't belongs to R. So R is not reflexive. Coming to the symmetric part, let XY belongs to R. What does this mean? X is wife of Y. Now, can Y be wife of X? Because X is female and Y is male. That is the meaning of the word. We have taken this word in this way only. So, Y cannot be Y cannot be wife of X. YX doesn't belongs to R. So this is not transitive, oh sorry, symmetric. Therefore, R is not symmetric. Before we answer whether this relation is transitive or not, we should once again see the definition of transitivity. This is the transitivity relation. When the relation is said to be transitive, if xy belongs to R, yz belongs to R, then xz belongs to R. If this yz doesn't belongs to R, no question arises that xz belongs to R. Are you getting my point? If only xy belongs to R and no yz belongs to R, doesn't belongs to R, no question. So in that case, the relation is always transitive. Now coming to this particular problem, x, let xy belongs to R. So x is female, y is male. Now can it happen that yz belongs to R? Y is a male. In our societal norms, in our present definition of the word wife, Y cannot be wife of someone else. So YZ doesn't belongs. So no question arises about XZ. XY belongs to R and YZ doesn't belongs to R. So how XZ can belong to the set? So this relation is always transitive. R is always transitive. This question is very tricky. You should not confused. You should not be confused with that. Now let us take one more interesting problem related to this definition, transitivity. Let A equal 1, 2, 3. 1, 2, 3. Let R This is another problem. Okay, R equal 1 1 2 2 3 3. Is R transitive? What do you think? R is always transitive here. 1 1, and no element of R begins with 1. 2 2 3 3. This is exactly using the same logic we have used in this problem. R is always R is always transitive. Remember this question. Okay.